Hello, everybody. Welcome to MEERTALK. My name is Kaiza Fern, and I'm the Director of Communications at MEER. We are really glad to see you, glad to be doing another MEERTALK. And today, we will be hearing from Professor Nana Klutse. Then we'll have a question and discussion period with people who are from the MEER community. And after that, we'll open it up for questions and from all of you in our live audience. Just an update about MEER. Dr. Tao will be attending COP28 in Dubai at the end of November. We think it's important for MEER to have a presence there. If you would like to contribute toward our efforts to cool the planet, we do appreciate each and every donation that you make. You can go to meer.org and click on donate, and we thank you so much for the contributions that you make. You could also write to community@meer.org to be in touch with us. So let me introduce our guest speaker for today. Professor Nana Klutse is Vice Chair of the Working Group 1 of the Intergovernmental Panel on Climate Change, the IPCC. She is Associate Professor at the Department of Physics at the University of Ghana and also the head of the department there. If anybody has any questions that come up while she is presenting, you can send those along to Peter in the chat, Peter Dines. Okay, Professor Klutse, we are really excited you're here today, and we're interested to hear what you have to say.
Thank you. I would like to share my slides whilst I welcome everyone. And in Ghana, it's good evening. It's maybe afternoon or some other time that side. So while I'll share my slide, I welcome everyone. So I would like to talk on climate change, a challenge of science, a challenge of development, and it's also a moral challenge. So as you can see on my screen, I have my email address also there. And so if the audience will want to interact with me, have further questions or any other thing, they can send me an email beyond this event. Okay, so once we're talking about climate change, it's important to give a broad perspective of what it is. And by definition from science, we say a significant shift in the mean state of the atmosphere. So here we have a diagram showing a clear shift. For example, the blue lines compared to, let's say, the red lines, or compared to those ones in the middle. Those ones we have the positive anomalies and negative anomalies. So any epoch you find or you look at, we can say each epoch compared to the other is climate change. So here we have three situations where we can clearly say the difference in the mean state of the atmosphere. So it can be temperature, it can be rainfall, it can be any variable in the atmosphere. So once you're able to see a significant change or shift over a period of time, we say there is climate change. Now, climate change is a normal component of the Earth's variability or natural variability, which means that if human beings lived on Earth or not, the climate will still change. The climate system or the change occurs on all time scale and all spaces. So at the global level and over time, we have climate change occurring. We have had several evidence showing that the climate has changed, several of them. And why is this a science problem? First of all, we try to understand why the climate is changing and what it implies for everything, including the existence of human and all that is around us. So our main energy input of the Earth is the sun. And so from the sun's radiation, we get the energy input, and the Earth is tilted in this manner, more like this manner. And so we have the sun's radiation more concentrated around the equatorial region. So we get more heat around the equatorial region, which then it gets transferred to the poles, the north and then the south pole. I use this diagram to explain the general circulation of the Earth. I wouldn't not do too much of the science. I won't go deeper in the science, but you can see these red cells are called Hadley cells. They are warm, and towards the poles, the north and the south poles, the heat get exchanged with the normal transfer of heat from hot to cold is how the Earth system circulate air around it. So this is air in circulation from warm equatorial region to the cold polar regions. And this is how the whole weather system occur over the Earth system or in the atmosphere. So this is a system which we try to understand. And another system we try to understand, this is just an example, something like mid-latitude cyclones. Why does it happen? And how it happens? When will it happen again? And the impact when it happens normally will have. So when we have temperature differences between two air masses, when we have that and we have a large differences between two air masses, they pass over each other. The warm air at the cold front rises and creates a low pressure system, which we see at the cell, these eyes we can see here. So this is actually a twin cyclone that occurred around Scotland. And we know the effects cyclones normally brings onto land. This is one system we want to understand. These are wind system over the oceans. So where you see the amber or yellow colors is the land where we live. And the gray colors are the oceans that we have around the world. We have large circulations occurring in the ocean, and they have effects on the atmosphere. We try to understand the system. We have events like ENSO, El Nino Southern Oscillation, which is an interaction between the atmosphere and the ocean processes. These are unusual weather patterns that occur when the Pacific Ocean is warm, and that is near the equator when it's warm. So these events are unusual. They occur from time to time. There are two phases, the El Nino and the La Nina, the warm phase and then the cold phase. So these affect the processes in the atmosphere. I'm skipping through all of these. This is not just the only process, but many of those processes, just an example. In trying to understand all of that, we also have the Earth energy budget, and we have the clouds in the atmosphere, the role they play, and the other components of the atmosphere, the role they play in all of these processes. So we have the sun, as I showed earlier on, getting the rays or sunshine to the Earth system. And if it gives the warmth or the heat that the Earth needs. The Earth as a system, as a body, also give off radiation. So these two effects, what we receive, what we call the incoming solar radiation or shortwave radiation, and the Earth terrestrial radiation or outgoing long wave radiation. The balance and the imbalance makes the atmosphere warm. And when we have other components or other components of the atmosphere can also increase the warmth or the temperatures of the atmosphere, or decrease, or let's say affect the temperatures of the atmosphere. So in physics, we put a simple climate model. We say we follow the rule. What comes in is what must go out. So this is a simple climate model where the sun's radiation is taken into effect. So what is coming from the sun, and what must go out is also the terrestrial radiation that is radiating out of the earth. The end effect is what we get as our average global temperature. Now, this average global temperature has this term here called effective emissivity. That's the greenhouse effect. This is where we have the effect of cloud in the atmosphere. Now, I present this simple model to also explain that we follow the natural process of the earth in trying to understand from science perspective climate change. So the greenhouse effect, we have the absorption of these components or gases of the atmosphere absorbed by solar radiation, and we have these gases also absorbing terrestrial radiation. So different components of the atmosphere, we have methane. We have so many gases, but these are the ones that have great effect on the atmosphere: methane, nitrous oxide, ozone, carbon dioxide, water vapor. So the last panel is the whole atmosphere together. So when the solar radiation coming through the atmosphere, it can get absorbed partly by methane, can get absorbed also partly by nitrous oxide. Actually, this is the infrared part, which is not warm. The other part is transparent through these gases. We have the ozone, which absorbs the hot parts of the solar radiation. We call the ultraviolet radiation. Then we have carbon dioxide. So these, and then water vapor. These gases behave differently when it comes to the terrestrial radiation. You have methane absorbing this same way, but then the terrestrial radiation has more of the cold part of the radiation, so the infrared part of the radiation. So we have methane absorbing the terrestrial radiation, a lot more of all these gases. So these are greenhouse gases in the atmosphere. So these will keep the atmosphere warm. So the more we have them, the warmer the atmosphere actually becomes. In the atmosphere, we have a mechanism called the feedback mechanism. So the natural atmosphere has its own checks and balances that it uses to get back to normal or get back to a balance. So it counter-reacts or checks itself to come into a balance. And we call this feedback system. This feedback system, so let's say if there's more of any component of the atmosphere, the earth system will react in a way that it will want to get to a balance. This feedback system operates simultaneously. They work all the time and in both directions. They are so complicated that it makes the atmospheric component difficult to predict. These feedbacks, as I said, they amplify, or depending on if it's positive, we have positive and negative feedback. So they make the atmospheric system complicated so through these gases also in the atmosphere, they each have their effect on the atmosphere and the variables in the atmosphere. Now we try to understand the effect of albedo, how reflective the earth or the atmospheric component is of the sunlight. We try to understand temperature through the balance of the sun, the incoming short wave from the sun radiation and the long wave terrestrial radiation, the effect of water vapor, cloud cover, and different components of the atmosphere. We term it as atmospheric dynamics. So even the effect of human beings, our existence, how many of us or the population per each area can affect the atmosphere. So we try to understand all of these components together and the effects they have. And that's a big challenge because we have many of these effects or features to deal with. So we use climate models in trying to understand these complexities. We know that in the climate system, it's not linear. So we say 1 + 1 is not necessarily equal to 2. So 1 + 1 can be 3 or 4 or 5. And in the course of my talk, you will understand what I mean by that. So we are limited by our understanding because we have complex system to deal with. And we are also limited by computing power to do modeling or trying to use computers to understand the climate system. We use what we call climate models, which we calculate all these processes I have spoken about earlier on the model. So a typical model, as you can see here, this round thing, this is how we divide the atmosphere. So the gray part, we assume that is the atmosphere, the envelope of air around the Earth. So the gray part, we divide them into small sizes we call grades because we can't model the whole Earth as one whole. So we divide it into small spaces so that we can run these on our computers. So for each of the processes we have discussed or I've talked about earlier on, we put them in as mathematical equations and we solve them per each grade that you see here, those small division. So each of the processes, we calculate this. So if there are 1,000 of these boxes or grades, the computer will have to calculate the processes 1,000 times. If there are 10,000, the computer will have to do the calculation 10,000 times. The calculation the computer is doing is trying to bring in the sun's radiation, the earth radiation, the clouds in the atmosphere, carbon dioxide in the atmosphere, all the gases in the atmosphere, together with, let's say, hydrological cycle. We have evaporation of water from the surface of the earth. It gets condensed in the atmosphere. It becomes water vapor. It turns into clouds. It can fall as rain. It can also stay there just as cloud. All these effects or processes are calculated per each small box. Now, the confidence we have in our models is that we use basic laws of physics and chemistry to solve these problems on these grades on the computers. So, for example, conservation of mass. I will not go into the equation. These are very basic equations, which is, the law of conservation of mass. We have first law of thermodynamics. We have Newton's second law, plus the water vapor I spoke about, plus the gases in the atmosphere, how the laws that govern gases as well. We have to calculate all these processes on computers. So if you have many calculations to do, it means you need big computing space or powerful computers. So we normally run our models on what we call supercomputers. And these are expensive, and so many institutions cannot afford, and we have only few of these supercomputers around the world, and they help with simulating of our climate processes. So through this, we tend to understand the processes in the atmosphere, how one thing affects the other, in trying to understand. However, so with all our challenges, we've still been able to make some progress. We are able to understand the current or the observe or the past situation or changes of the atmosphere, and we are able to project into the future. So we are, through this, we can confidently talk about how the temperatures have changed over the years and how it will change even in the future. You can also see from this graph that we have the black lines, which is the observed, so what is measured. We have the red, that is the temperatures when we have human influence and natural drivers of the climate system. So the green is when we have only the natural changes or natural drivers of climate change. So as I said earlier on, whether human beings live on Earth or not, the climate will change. And I will explain our concern as well as I go. So you can see that the green, there's also changes. However, it's not going high in terms of temperatures. So these are temperature anomalies. Now, temperature change in the last 50 years of the whole globe. This is from Wikipedia, but these are from IPCC figures. So we are able to compare the last couple of years to the future. And we can tell how the temperatures have changed. And that's, of course, significantly we say climate change. I use this boiling frog as a fable to explain the urgency of climate change. So I compare this with COVID-19 all the time. We seem to be talking a lot about climate change, but it doesn't look like we are acting according to the urgency the climate change is now. These frogs, when you put a frog in water of normal temperature, a boiling water or hot water, the frog will jump out immediately. So that is like a situation we had with COVID-19. The whole world came to a standstill and we needed immediate solution to the pandemic, COVID-19. The climate change situation has become like putting frogs in normal temperature water and applying heat slowly underneath. So you are boiling the water underneath slowly, and these frogs can try to be adapting in the water. So the temperature of the water is increasing, but then they are able to continue to adjust until the water starts boiling them in there. So we are slowly getting boiled, or the globe is slowly warming, and we don't see the urgency, or even if we see, we are not acting it the way we paid attention to COVID-19. Now, climate change has happened on Earth, but as I said, it's a natural process, but the rate at which it is happening now is the concern. The rate at which the temperatures are increasing is actually overwhelming. And we have seen several evidence that human activities have contributed to climate change over the past centuries. While so the solar activities, as I said, the imbalance of solar radiation and terrestrial radiation also gives climate change. We have volcanic eruption, which is natural, and these natural activities compared to human drivers or human activities are drivers of the warming is really minor. So the natural drivers play minor role in these changes we are talking about. I was restraining myself using warming, but then it's important to also talk about climate change, how it compares to global warming. So climate change and global warming are often used interchangeably. Of course, there are differences in the meaning. So they are different phenomena. So where we say global warming is an increase in the global temperature. When you compare, it's an increase. So definitely it used to be probably a lower temperature compared to today or the reference year we're talking about. But climate change also includes a warming like that. So once it has warmed, it means it was once cold and now warm, it's a change. So it's climate change. So climate change can mean also global warming. But these, whether you use them interchangeably or not, of course, they have different definitions. And they have side effects. So climate change is a side effect of global warming as well. So when the temperatures of the earth warm, it changes the circulation pattern, it changes a lot of processes in the atmosphere. And when it warms even more, there are a lot of consequences which I'm going to show. So why are we concerned? Because it's affecting our environment, and even climate change has the potential to destroy our very existence. It's affecting the air we breathe, the water we drink, the food we eat, the environment we live. It's affecting it. And climate change is everybody's business. So if you are benefiting from burning of fossil fuel, so if you sit in the planes, if you drive a car, you are also causing global warming or climate change. So if you are involved in land clearing or you live in a house, it means some land, probably some forest was there, which has been cleared for the house to be built. You have also contributed to climate change. How responsible or how much we contribute in this sense depends on how rich or how poor we are. So we say countries that are rich countries, developed countries, have contributed more. People who are rich contribute more because you see rich people driving big cars, poor people may walk or use bicycle. So our lifestyle, our consumption patterns are all dependent. So we add or we contribute to these global warming issues or climate change. However, we say we have an ethical dilemma because whilst the rich contribute more to climate change, the poor suffers the more because the poor do not have the adaptive capacity to withstand the effects or the impact of climate change. So we have an ethical dilemma here. What we have to do is to try to mitigate or reduce greenhouse gas emission to reduce climate change. Otherwise, as we are now, as happening, we can adapt or prepare for unavoidable climate change. So our government, everything that we do, we have to be working towards adaptation. We have consequences of climate change. The glaciers are are melting because temperatures are increasing and they are melting the ice at the poles. So we have Greenland, Antarctica, those areas, they used to have a lot of ice or glaciers that are melting. So this picture compares 1957 to 1998, how these ice are melting in these areas. And when they melt, of course, it becomes water, and at the end, it runs into the sea, the oceans, and it's causing sea level rise. Sea level rise has become a big global challenge. The sea level is increasing approximately 0.2 meters per year, and that is alarming. Many countries with coastal cities are losing their habitats, people are losing properties, livelihoods, homes, and all of these challenges. It's projected that you can see these lines. It's projected that the sea level will continue to rise, and this is towards the end of the century, if we continue to behave the way we behave and adding to the greenhouse gases in the atmosphere. If you have watched Happy Feet, these are penguins and they live in these ice and glaciers areas. These animals are losing their habitats as well because their homes are melting. If you have watched Happy Feet, you'll be sad to see that these ice are melting. The sea level rise, if the sea rises by 1 meter, many countries will lose land areas into the sea. So we have Africa losing about 100 kilometers square, 100,000 kilometers square. But compare that with Asia. Asia will lose a lot more land mass when the sea rises by 1 meter. A country like Bangladesh will probably lose Bangladesh completely in a few years to come. Number of populations affected in millions if the sea level rises by 1 meter. It's also projected this way. A lot more people will be affected. Same way it will affect the countries or the continent GDP. And so you can see a lot more happening for Asia will be most affected with sea level rise. So that is on ice melting and with the warmth. We have increased frequency of extreme events, and this is also caused by the changes we are having in the climate system. We have been hearing news or experiencing dangerous hurricanes, heavy rainstorm, because once the atmosphere gets warm, the oceans are also getting warm, and even the system I showed earlier on, these hurricanes are happening more frequently than it used to happen a few years back. We have also had heat waves and wildfires happening more frequently in many more areas than it used to be in a few years ago. We are having or experiencing heavy rainfall that is causing flood in many cities in the world. We experience droughts in many cities as well. So these are all affecting us because we need to adapt through these events, and the adaptation plans, or programs, or actions are really very expensive, and I will show that as well here. So this is a projection of future costs of adaptation. I'm showing you for Africa because that is what I have data on. So the impact of climate change, if we have to have our adaptation actions implemented, it will cost Africa 2.7% of its GDP. This percentage varies, will vary for different regions. Some are significant. So this is from UNDP, information from UNDP. And you can see the map of showing the different range of GDP that will be affected over the region, projected up to 2030. So which means that even now, governments are spending on adaptation actions. There are more, so more is going to happen even into the future. There will be more costs of adaptation because these events are happening. They are currently unavoidable, and we need to try to live through it. We need to adapt. Developing adaptation structures are not, should I say, cheap. They are expensive. The IPCC Sit Assessment Report was clear and bold, red-coded for humans, issues of climate change. So these titles you see in the news are for real. Scientists have proven that human influence has warmed the climate, because the natural influence is not, it's minor, as you can see in this green line. So this is the natural drivers of climate change. So if human beings didn't live on Earth, this green is how the climate will change. This is temperature anomaly. So which means that it will change, but it will not be high temperatures. Today, with humans living on Earth, we can see clearly the observation of temperatures at the global scale. And the mauve color or the violet is humans together with natural drivers of climate change lines. So I showed something similar earlier on, and these are also, I mean, this is recent from the State Assessment Report. So these are global temperatures relative to 1850 to 1900 compared to compared to today's temperatures. Clear changes in the climate system. So this is temperatures. I said earlier on that with the greenhouse gases in the atmosphere, and I'm showing only for carbon dioxide, we have real measurement of carbon dioxide in the atmosphere. So from 1950, as we can see, up to 2021, we can see a clear increase of carbon dioxide in the atmosphere after 1900. So this is the story we are preaching. This is the issue we are concerned with. As carbon dioxide increases in the atmosphere, it supports greenhouse gas, in the atmosphere, and the greenhouse effect is high, intense, warming the atmosphere and causing all these changes that we are experiencing today. The two gases are mostly talked about, and why do we focus on them? Methane and carbon dioxide emissions. So if methane does not get, so that if I use destroyed, it can be used up in the atmosphere through chemical reaction, chemistry. So if methane doesn't get reacted and change to another form in the troposphere, it moves a little bit up in the stratosphere and it can stay approximately for 12 years. For carbon dioxide, it can last between 300 to 1,000 years if it added into the atmosphere. So this is a concern. So if we stop whatever we are doing now in adding methane and carbon dioxide in the atmosphere, we should know that the carbon dioxide, which we have already put in the atmosphere, is going to stay there for 300 to 1,000 years and will continue to warm the temperature of the atmosphere through these years. We have no time, the IPCC says we have no time. The global temperatures have already risen by 1.1 degrees Celsius and will probably rise further by 3 degrees or even more by the end of the century. The ocean temperatures have also risen. Glaciers and snow cover have decreased, as we saw earlier on. Cold days, nights, frost have become rare. Hot days, hot nights, heat waves have become more frequent. Sea level rise has doubled, and the poles are also, they continue to melt. We have seen the surge in carbon dioxide levels, and they are too much for plants to even take up. And we keep cutting trees and building houses. And so the trees that are to take up the carbon dioxide in the atmosphere are less than the amount that is available in the atmosphere for them. So more concentration in the atmosphere than the trees can even take up. There are lots we are doing. And so the IPCC will say we may be reaching or approaching the tipping point where we lose control over the climate change, or our understanding of the climate change or the atmosphere will not be the same again. I'll show that, I'll do a demonstration here for you to see. So this is how this is the Earth, and just demonstrating how the Earth is warming, the temperature is increasing. So as the Earth go on the inclined plane or climbs the inclined plane, it demonstrates the warming. So at any point on the inclined plane, this Earth can get back to its original state when we stop pushing it. So let's say we're pushing it with the warm or with the greenhouse gases in the atmosphere. Anytime we stop this warming or the Earth can come back to its original state. But then when it gets to this tipping point, this pointed pivot, it cannot. So beyond the tipping point, the Earth or the warming, we can have control over it again. It cannot come back. It cannot come back to its original state. So this is the advocacy. We should try as much as possible to keep the warming within 1.5. We should not go beyond 1.5 degrees Celsius. And that is the Paris Agreement, that we should not reach 2 degrees Celsius. And if we can work hard to get 1.5. We've lost hope already in this global goal, because as we speak, the Earth has warmed more than 1.1 degrees Celsius at the global scale, which means other regions like Africa, for instance, have warmed more on the average. So when the globe warms by 1.5, Africa will warm more than 2 degrees Celsius because it's already a warm region. So this is our concern, and all of us have a role to play in trying our best to reduce the greenhouse gases in the atmosphere. The Earth is already overstretched, and we don't know how much more of our activity will make it go beyond the tipping point. So I use this glass of water as an example, that we don't know the state, how full or how warm the global temperatures are, or the Earth is already. So let's say we already have a glass full of water. So that is the state that we are in. This glass, which is already full, may allow you to add a few more drops. Just go on it. A few more drops can be added, but you can continue to add until one drop that will cause this water to overflow. And when it overflows, it will not overflow that last drop. It will overflow with many more drops. And that is the advocacy we're making, that let's try to be morally right towards the Earth, so that will limit or be moderate in our activities that actually harms the Earth. So this is the little I plan to present to my audience. Thank you, and I'm ready for questions.
Thank you so much. Those were really, really great visuals that I think drive the point home. We're going to bring on a couple of people who are MEER volunteers to ask questions. And meanwhile, if you from the audience have any question, you can go ahead and send them to Peter Dines in the chat. So first we will bring on Kathy Posey. Kathy Posey is an educator by career and has a varied work background, including public diplomacy and administrative support. She currently volunteers in an administrative capacity for MEER. So welcome, Kathy, and go ahead with your question.
Hi, thank you, Professor. We really appreciate you being here. And laying out so concisely where we are, and the dire situation that we are in. And I think that probably very close to 100% of people tuned in today are pretty aware of how dire the situation is. And so my question would be for you, clearly you're educating and you're taking this message and making it very understandable for a general public and taking it to COP28 and to your students and other places. I just would like to ask your advice to us, those of us tuned in who probably are aware and care very much about our situation. How do we spread the word effectively, and just anything that has gone really well for you and perhaps the students that you influence in getting this word out and making more people really aware of our situation?
Thank you, Kathy. I think, first of all, when you are aware of the challenge or the problem, that is when you start making effort to solve it. So as you said, we need to make everyone aware as much as possible, the situation, the urgency to do this. I believe that once you have heard about it, you have read about it, you have some level of knowledge about climate change, you can talk to your friends. If you have bigger platforms, if you have social media handles, keep talking about the urgency of the situation. It's not also just about talking, but also presenting what we can do in our individual capacity towards helping reduce the emissions of greenhouse gases in the atmosphere. So there's so many things. If you don't need light in your room, why leave it on? If you don't need air conditioning, why turn it on? If you can use the natural windows, the natural air, open your windows, get fresh air from outside. If you can walk, why drive? If you can, there's so many ways we can help reduce. These are small things, actions, like the small drops of water that we can do in our individual capacity. If you are in another capacity, like government, like policy, you could also act at that level. Government can, apart from adaptation actions, we should need to also have mitigation actions. We can bring up policies that support mitigation, that helps us to move from our traditional use of fossil fuel to thinking towards mitigating climate change. So many of these things we can all do in our individual capacity or in other capacities that we may find ourselves. So I believe that we all have a role to play wherever we find ourselves. We do have.
Definitely. Thank you. And then just another, I enjoyed the map that you showed of Africa and how the adaptation needs are not going to be equal everywhere. Would you mind highlighting an example or two of some of the areas that are being hit the hardest and what kinds of adaptation strategies people in that region are using?
Okay, thank you. So if we use, for example, coastal cities or countries with coastal cities, currently they are struggling with sea level rise and high tides. And so it will cost a lot more to, say, evacuate people, relocate them, give them livelihood or sustainability than countries that are inland. And sometimes these events are also come in their numbers. So whilst we have, let's say, this coastal erosion, we may also have flooding at the same time, affecting other parts of the city or even the same coastal area. So we can have double event occurring. So compare that to cities or countries that are inland. They may be experiencing probably floods or droughts altogether, but then some countries have other events, some do not have. And so it adds to the adaptation cost. Some countries also already have some structures that are resilient to climate change. And so it only can come as a little add-on to the people's adaptation. So depending on the environment, some people are living already in highlands, and so they don't get affected by a flood that much. But of course, they are subjected to drought as well. So depending on the topography as well and where they find themselves, the cost of adaptation can differ. Yeah.
Thank you so much.
Thank you.
Thank you, Kathy. Next, we'd like to bring on Helen Payne. Helen Payne has many years of experience as a technical team lead and data architect. She is currently a volunteer assisting on updates to MEER's strategic plan. We're glad to have you, Helen. You can go ahead.
Thank you, Professor. I enjoyed your talk very much. I appreciated particularly your discussion around tipping points, because I feel like so much of the discussion we hear in mainstream media tends to talk about projections such as X number of feet of sea level rise by the end of the century, or within the next 150 years, you know, something dire will happen, which I think tends to lead people to believe still that
We have time.
serious effects are way off in the future. But the tipping points, which, you know, perhaps we're already passing some of them now, could make a huge difference. In your professional opinion, how much time do you think we have really left before we start running into things like the collapse of the global food supply, or things like this, that it doesn't matter what your GDP is, you have a major existential threat. So where do you think we are really?
Yeah, thank you. Let me use the scenarios that we normally use to do the projections, and that helps us to also plan policies and actions. So we have used in the past a scenario called RCP 2.6, and that scenario is when we decide as humans to stop the use of fossil fuel, which means that we're going to cut down tremendously the use of fossil fuel that adds more carbon dioxide into the atmosphere. So if we are hard on ourselves, then we can have a warming that is, like, I would say, more friendly. And so we'll not have the glaciers warming, melting, and all these effects that we are having now. The impact will reduce tremendously. Then we have a scenario which is like midway, RCP 4.5. That is when, if we try to be moderate, so we're not so hard on ourselves, and then we have also we know that this will have effect, and so we try to be moderate on our actions that add to greenhouse gas emission. We also have projections on how the world or event of the climate system will be like, which is something or event that will give us a bit of time and not too harsh as we have in it today. Then we have another, so we have different scenarios. So we have another scenario that is RCP 8.5. In that scenario, we call business as usual. So we continue to behave the same way we behave, increasing our population, clearing the forest, building new houses, and all those things, then we are going to have really, really difficult times because the globe will warm much faster and the associated effects will be more devastating for us. As we speak, we had put timelines on these scenarios. So it's like saying, okay, let me just go straight. So we put timelines. So for the 2.6, which we had to be hard on ourselves, we have already failed because we could not be hard on ourselves. So we are now in the midway, trying to advise ourselves, negotiating with each other to try to cut down greenhouse emission. So we have seen technologies like electric cars being used, and we've seen renewable energies being used. Advocacies are all over. So people are kind of paying attention slowly. But I think we should have the urgency and act, or our actions should be, we have to be more radical. So, but as we speak, I still think that we still acting business as usual, really, because we could do much more than what we are doing, but we are not doing it. So I think we don't have time. We don't have time at all. We just have to be hard on ourselves as much as we can. It has so many other implications anyway. That is why we have the conference of parties to sit and talk. We have categories of countries. We have developed countries. We have developing countries. We have least developed countries. Especially the least developed countries, if they have the opportunity and the capacity, they also want to be like developed countries. They want to have buildings, they want to be developed. So you know what I mean? They want to have their road networks and everything done like the developed countries. When they're going through that process, obviously it will add to greenhouse gases in the atmosphere, which means that they are going to clear their forests to develop their lands. But then when we sit at conference of parties, if a developed country want to talk to a developing country or least developed country, don't cut your trees. What are we trading off our trees for? So countries, so this is a simple example at COP. So countries sit together and negotiate. Okay, you bring me technology like renewable energy, solar panels to use. Instead of cutting my trees, we replace or we trade off that with something else. So it can be cash, which countries or developed countries can give to developing or least developed countries to build adaptation structures. It can be knowledge transfer, it can be exchange of expertise. So conference of parties are there for these exchanges so that we all make effort in trying to reduce the greenhouse gas emission as well as trying to adapt to the effect of climate change. Thank you, Penny.
Well, thank you. Just real quick, since you sit on the work group for the IPCC and other groups, are you optimistic that we will, as a global community, be able to come together to solve the problems that are immense?
We need a clear paradigm shift, like COVID-19. Something that will wake us all up one day to be able to do this. We saw the level of collaboration, the level of co-design, co-production, a lot of discussions bilaterally at the global scale that we did around COVID-19, because it came as a pandemic. It was so urgent and it was affecting everyone, and everyone was, I would say everyone was in that state of fear. So if we have a paradigm shift that will cause all of us to wake up to the issues of climate change, I believe we will act accordingly. as it is now, you don't call for doom, but because we are able to adjust, adapting, it's like we are not doing what we are supposed to do in terms of the actions, discussing at the global scale to work together. Countries have interest, obviously. And so, I mean, it's a little bit difficult. We hope that Conference of Parties will get to a point where we can have honest global discussions to be able to drive this process forward. Thank you, Ellen.
Thank you, and thank you for your role in trying to help us get there. Thank you.
Thank you.
Thank you, Helen. So now we're going to open it up to some questions that have come in from our live audience. Here's a question about clearing forests, something that you mentioned. Low-income households clear forests for food and shelter, even if it's a limited amount of that. But mitigation education should not overlook their situation. So how can we include them in the picture?
Thank you. That's a very real situation in lists or rural areas, if I may put it that way. That is where they have energy for food and heat and light. So if you go with the mitigation education, there should be an action also towards that. If I should not cut my tree, what do you offer? So we have solar cookers, we have solar lamps, we have solar ovens, we have alternatives which we can deliver, we can give out. So a negotiation like opportunity like COP, for instance, these discussions can come up for what we can trade off what we normally or our traditional lifestyle to some other lifestyle. But the caveat here is that this is the culture of some people. This is their way of life. It's difficult to change, but it's possible. So then we have to find ways to do it slowly, but steadily until we can have such a change. Otherwise, technologies like that get abandoned, although they are important. Because of cultural differences, it doesn't work until you slowly do the education and I mean progress in that space for the people. So it's doable.
Right.
Thank you.
Okay, thank you. So I have, Diana has asked a question about, so travel opportunities in airport construction are on the rise. Tour operators claim to be eco-friendly. And Diana says their retired friends love to travel. Any ideas on how to raise awareness about responsible travel among rich retirees?
Well, thank you. That's one of the difficult situations we find ourselves in. So in trying to advocate for reduction of greenhouse gas emission, when we go to sit at COP, we have 40,000 delegates flying to one spot, one place. And if you calculate the carbon footprint there, it's huge over 2 weeks of travel. So it's a difficult situation now that we don't have alternatives. I wish these virtual opportunities that really got popular during the COVID time can be more popular even now so that we reduce travels. But I don't know how we'll do holidays virtually. It's a difficult situation. So we can be moderate. I mean, it should be responsible travels, as he rightly mentioned in the question. So we should be aware and of course, avoid troubles that we can avoid, but we still have to live in this process. I mean, we can't die trying to live, so we still have to live in this process, but we should be as moderate as possible, sure. Yeah.
Okay, I have a question from James. In our attempt to reduce carbon emissions, electric vehicles are a necessity to replace fossil fuels. Is there enough lithium resource to power this change?
Yeah, I would say yes, we do. We have huge deposits of lithium around the world, especially in Africa, we do have. And so we just need to have the right technologies to be able to make use of these. Even to fly planes, people are into research, and we hope that gets developed more. Like we have electric cars. Hopefully one day we'll have electric planes. Technology is developing. We are not yet there, but we hope that we can get there one day. So as I said, climate change issue is everybody's business. Every field can have a contribution, from archaeology to zoology. Everyone can have a contribution to solving this paradox that we find ourselves in. So technology is very important. Today, AI, people are using AI to help with prediction, machine learning. We didn't used to have that in the past, but now they are coming in to help give us much better forecasts of weather and predictions of climate events. So we're getting more accurate processes now than we used to have. And these are not originally climate trained persons. They're completely AI or computer scientists or something, but they come in handy to help in this process. So we need the technologies as much as possible, especially to solve this problem.
Yeah.
Thank you.
Here's a question. Does the IPCC include the impact of global conflicts, such as, for instance, Ukraine, which has been going on for so long, but then more recently, of course, in the Middle East, things happen that we don't predict that have effects on the climate?
Yes, so the IPCC, the IPCC does the assessment of science of climate change. So it's a UN body that does the science. So the IPCC does not start research or on its own. It assesses the publications or research that is already out there, collects all the information around the world about climate change. So we have 3 working groups. Working group 1 looks at the physical basis, the causes of climate change, what is causing, the evidence and all that. The working group 2 looks at the impact and vulnerabilities. So where I talked about, let's say, coastal erosion, it will be reported same. So the Ukraine-Russia war, for instance, if that has impact on the climate system and the other associated implications, it can be reported in working group 2 or working group 3. So if, let's say, they shot some guns or they flew planes and all that, that added some greenhouse gases in the atmosphere, it will be reported in working group 3. So working group 3 looks at the mitigation strategies and actions and all that, publications on that, and report same. So these 3 working groups have the physical basis, the impact and vulnerabilities, and mitigation. So anything that is about climate change, once there's a publication on it or a number of information out there, the IPCC will assess it and report same to the world.
Okay, that's great to know. I have 2 closing questions. One is, you mentioned earlier that climate change and global warming sometimes are just used interchangeably. And people don't know that they're just using them maybe interchangeably. What do you think that's a bad thing? Or, should people be really specific and say, be using global warming in certain, or in all cases at this point?
It actually depends on the context. As I said, you can use them interchangeably because global warming, it's also climate change. In fact, you can define climate change as global warming completely because it's a temperature that has changed from one point to the other. It's a change. So if that is significant, you see a significant change in that sense, then you can call it climate change. But then global warming is the increasing temperatures of the globe. So they have their clear definitions. However, because the warming is a change of a state in the temperature, you can say it's climate change. So as I said, you can use them interchangeably, but it's also in the context of which you may be using them.
Okay. And finally, I'm curious about how knowledgeable does it seem like the general public that you're in touch with is about this in comparison with, let's say, the students who you work with and you teach, and I know some of them are here. Welcome to all of you students here. Yeah.
Yes, so for the students, you will say, of course, they get in-depth knowledge and understanding because they also will read and go through the courses. But then you go to the general public, they might have heard that there's climate change, and they can also may point to one or two observations that they have experienced. They can also point out to other events they have heard in the news, and that's referred to as climate change. But they may not have an in-depth understanding and even what to do. So the continuous advocacy will help for everyone to know what is really climate change, why it's happening, and what we all have to do together to resolve or support this process.
Yeah. Well, thank you. We want to just say thank you for coming to MEERTALK and for speaking with us. We want to wish you well when you attend COP28. And yeah, thanks again. This was really wonderful.
Thank you. Thank you very much for the opportunity.
At MEER, we are working to help educate the public while also develop a solution to the warming on the planet. We invite you to keep learning about Earth's energy imbalance and climate science on our website. We're an almost 100% volunteer staff, so please do consider making a monthly donation of any amount if you've enjoyed being here and have learned something. You can check out our YouTube channel at MEERSRM and also social media, of course. So if you've found it beneficial, please tell somebody else about MEERTALK so they can come next time. And we hope to see you on Sunday, December 3rd, when Peter Carter will be speaking about the rapidly deteriorating climate emergency and the MEER initiative. So take good care until then. Good to see everybody.